So last class we have seen the working of three-phase half-wave uncontrolled rectifier using diodes. Okay, now in this lecture I'll be explaining a three-phase half-wave controlled rectifier. The difference between this uncontrolled and controlled rectifier is that instead of diodes now I will be using SCR or thyristors. Okay, so this is the circuit diagram. We have three voltages VA with respect to neutral VAN, another voltage VB, VC. These are all phase voltages connected. Okay, and in one VA I will be using a thyristor T1, here another thyristor T2, another thyristor T3. Now all these are connected together to a load. Assume that is a resistive load. Okay, so this is the circuit diagram. VA, VB, VC are the three phase voltages. T1, T2, T3 are three thyristors, and R is the resistive load. Now let's draw the waveforms, and I'm going to draw the waveforms for alpha is equal to 30, alpha is equal to 60, etc. Different angles you can draw the waveforms. How this controlled rectifier works, and always remember that all these thyristors are connected in common cathode configuration because the cathodes are connected together, and in common cathode configuration the thyristor whose anode potential highest will conduct at a time. That's the important point. So based on that you can easily draw the waveforms. So first we'll draw the source voltages. To draw the source voltages you have to mark all these things: 0, 30, 60. This is very important. In terms of this 30, 60 and 90 you should mark. Then the waveforms you can draw easily: 60, 90, 120, 150, 180, 210, 240, 270 and 300, 330, 360, 390, etc. Up to 540 you have to draw, then only you can get a complete waveform. Okay, so here the space is limited, so I'll be drawing up to 390 degree. Instead of writing this pi, 180 is pi and 360 is 2 pi. Instead of writing this pi and 2 pi, we are now writing in terms of 30 degree angles because we can precisely draw the waveforms. So the first voltage VA will start with 0, so it will reach its peak value at 90 degree and it will come back to 0 at 180 degree, and again it goes to peak value at negative peak at 240, and it goes peak value at 270 here minus, and come back to 0 at 360 degree. So this is VA, a normal sine voltage. That is VA. Okay, now VB is 120 degree displaced, so we can draw VB in this way. After 120, this is VA starting in 0, so after 120 degree you can start VB. So at every 90 degree the waveform goes either peak or come to 0, or it goes to negative peak, so you can draw in that way. So 30, 60, 90, so it goes to peak value at this point at 210. Now 30, 60, 90, at 300 it goes 0. Okay, 30, 60, 90, at 390 it goes minus negative, and it goes on like that. Here also you can extend it to left side, 30, 60 and 90, so at minus 30 it goes to negative value. It's like that. So this voltage waveform is actually VB. Okay, next we can draw VC also. So what is VC? It's compared to VA, this is 120 degree displaced and this is 240 degree displaced. So it starts with the 240 and 30, 60, 90, it goes peak value at 320, and 30, 60, 90 it goes the negative 0 at 420, and you can extend this 30, 60, 90. So here comes the negative peak, 30, 60 and 90. At 60 it goes to 0, and 30, 60, and it goes in this way. Okay, so this is the three voltages VA, VB and VC. You have to mark this. Now Let me mark the points of natural commutation. This is point X and this is point Y and this is point Z. What is the meaning of point of natural commutation? At X or beyond X, VA will be at higher potential, so the thyristor connected to VA will be conducting, or others will be in off, because all these are connected in common cathode configuration. And after Y, the thyristor connected VB is at higher potential, so the thyristor connected to VB will be conducting, others will turn off. And at VC or at Z, after Z, the thyristor which is connected to VC, that is T3 only, will be conducting, others will turn off. Okay, so these points are very important, X, Y, Z. These are the points of natural commutation. So this is 150, Y is at 150 and Z is occurring at 270 degree. Okay, now I am going to draw the waveforms. First I am taking, let's say, where alpha, what will happen if alpha is equal to 30 degree. So alpha is equal to 30. How will you mark alpha is equal to 30? Okay, so we know that after X only VA will be conducting. VA will be at higher potential, so the thyristor T1 will be conducting after point X. So the 30 for all these thyristor means this is the point of starting point. X is a starting point. So 30 from here means this is the value. At 60 you can fire T1, that's the meaning. So this much angle will be 30. Always remember that this is a starting point and not this 0. This X, Y, Z are the starting point. So the firing angle when you take 30 degree means you have to take from this point X. So at 60 degree only you will be getting, you can fire T1. Okay, similarly, how to fire T2 at 30 degree? T2 can start its firing at Y. So at 30 degree means after 150, at 180 you can start T2. Similarly, at T3, 30 degree means what? At 270 is its starting point. So from that 30 degree means at 300 you can trigger T3. Okay, so T3, T1 will be fired at 60, T2 will be fired at 180 and T3 will be fired at 300. In fact, all the thyristors are fired at 30 degree angles with respect to X, Y and Z. Okay, after that point of natural commutation you take 30 degree. Okay, so the thyristor will be fired here. Now let's draw the waveforms. We got the firing angles. Now let's draw the output voltage for alpha is equal to 30 degree. So how to draw the output voltage? Okay, so at the X I am going to fire T1. T1 is conducting. So when T1 is conducting, T2 and T3 are in off state because it's a common and cathode configuration. It is at higher potential. This T1 is at a higher potential. VA is at a higher potential, so T1 can conduct. So when T1 is conducting, others are in off. What is the output voltage? VA will be the output voltage. So after this point, whatever may be the value of VA, that you can copy. And what happens when it reaches Y? Okay, at Y the potential of VB is going to be higher, but you must remember that the thyristor T2 which is connected to this VB has not triggered yet. It will be triggering only at 180 degree. Okay, so until this 180 degree the phase VB is in off condition. The meaning is that VA will be a higher potential at 180 degree, even though VB is going to be high because it has not turned on. Okay, so only one phase is still active, that is VA. So VA can go up to 180 degree. Okay, so after 180 degree VA will go negative. What happens to this thyristor? Thyristor will be in the off condition, so thyristor cannot conduct. So at 180 degree, up to 180 degree, this VA can conduct because we have not started the triggering of the thyristor T2 at this 150 angle or at Y. It can go up to 180 degree, that is the meaning. So from this point 60 to 180 degree T1 will be conducting. Okay, so when T1 is conducting, output voltage is VA. So from 60 to 180, whatever may be the value of this VA, that you can copy and paste here. Okay, so this is actually VA. You can draw neatly in your notebook. Okay, now at 180 degree I am going to fire what, the next thyristor T2. Okay, this T2 will be fired. So when T2 is fired, what is output voltage? VB is the output voltage. How long this T2 can conduct? Theoretically T2 can conduct until this point Z, because after Z VC is going to be higher, but we have not turned on this thyristor. We have not yet started the triggering of this thyristor T3 at this point. We will be triggering only at 300 degree. Okay, so the thyristor can conduct until this 300 degrees. So T2 will be conducting here. So when T2 is conducting, what is the output voltage? VB. So we can copy whatever VB is here and draw here. The same VB you can copy and paste here. Okay, similarly T3 will be conducting from here, so you can copy this VC value from here. T1 is conducting, output voltage is VA. T2 is conducting, output voltage is VB, and T3 is conducting, output voltage is VC. Okay, now I will draw one more waveforms for alpha is equal to 60 degree. Okay, so now you will understand the difference. So alpha is equal to 60 means first you have to mark the firing degrees. Okay, first you have to mark the firing degrees. So this is the firing 0 points. X, Y and Z are the firing angle reference point or the 0 points. So 30 means this is 60. Now I am going to draw for alpha is equal to 60. When alpha is equal to 60 means 60 degree from this point. So it starts from 0 and you have to take the 60 from this point. So when you take the 60 degree from this point, it actually ends up in 90 degree. So you can trigger T1 here. From here also you can take 60 degree. From the point B you can take Y, you can take 60 degree. So it is at 120. And from Z you can take 120. So this is T3. Now I think you understood it. These are the reference points. From that you have to take the firing pulses. Okay. Now we can draw the waveforms. T1 is conducting from here, so the output voltage is equal to VA. Okay, so how long T1 can conduct? So we know that this T1 is started here, and after this point VB goes higher, but VB has not triggered it. VB will be triggered only at this 210. I mean the thyristor connected to this VB will be triggered at this 210. So this thyristor going to conduct until this 180 degree, and after this 180 what is going to happen to this VA? VA is going to be negative, so thyristor will automatically turn off. So the maximum conduction for the thyristor is until this 180 degree. So this is a T1 interval. So whatever VA available in this interval you can copy and paste here, and then 180 to 210 T1 will be in off because VA is negative. T2 has not triggered yet, so T2 will be in off. T3 is still negative, so T3 cannot conduct. So no devices will be conducting. So 180 to 210 output voltage is 0 because no device is conducting. Okay. Now at 210 T2 has triggered. So when T2 triggers, what is output voltage? VB, and VB can conduct until this point, right? So VB can conduct until this point because after this VB is also going to be negative. It will be turned on. VC has not triggered yet. Okay, so similarly you can draw this VC pattern also. Okay, similarly try to draw for alpha is equal to 90 degree. What is going to happen? So you'll get another kind of waveform. So this is the basic technique for drawing the waveforms.